So we're going to continue our discussion of derivative rules with the next rule, which is called the product rule. And you probably guessed it has something to do with products. So we've talked about the power rule, we've talked about the constant rule, the constant multiple rule, and the sum and difference rule. But that doesn't cover all the different functions we're going to see. So this product rule covers products. What happens if you have something times something? So if both f of x and g of x are differentiable, meaning you can take the derivative of them, then so is their product. So is f of x times g of x, and this is the product rule. F of x times g of x prime, the derivative of that, is the first function f of x times the derivative of g of x, g prime of x, plus f prime of x times g of x. So essentially what you do is you multiply each function by the other function's derivative. Okay, and I've written it out there in words. The derivative of the product of two functions is the first function times the derivative of the second plus the derivative of the first function times the second function. But I usually just remember it as fg prime plus f prime g. All right, leave out the x's. So that is the rule. Okay, and we want to prove that rule because if we're going to use it, we need to make sure we know that it actually works. And what we do is we always go back to our limit definition of the derivative. So we're going to start with a function that is f of x times g of x. And we're going to go, okay, well that means the derivative of that function, I'm just using a capital F of x, is capital F of x plus h minus capital F of x over h. So when I plug in, I'm going to put wherever there's an x in here, I'm going to put an x plus h. Oops. So that's what it's going to look like when I'm done. And when I look at that, I say, well, there's an f of x plus h there and a minus f of x there. So that's kind of the derivative. Then there's a g of x plus h there and a g of x there. So that's kind of the derivative of g, but they're not together. And so what I'm going to do is I'm going to put in a term. I'm going to add a term in here. Okay, and subtract it. So you might be wondering, what in the world are you doing that for? But what I'm doing is I'm taking this term right here and right here, and I'm adding it in. So why am I doing that? Well, I'm doing that because that is going to then give me a common factor of f of x plus h in here. And here it's going to give me a common factor of g of x. Okay, so I just took minus f of x plus h g of x, and then I went plus f of x plus h g of x. And what that results in, if you then take out our common factor, is this. And I'm sorry that it's kind of on two different planes, but we take out f of x plus h from here, first of all. So we're left with g of x plus h minus g of x all over h, so that's where I'm getting this from. Here I'm going to take out g of x, and I'm going to be left with f of x plus h minus f of x, all divided by h. Okay, and so then what I'm going to do is I'm going to let h go to 0 just in here, so that term is going to become f of x. The other one I'm not going to be able to, because if I let h go to 0 in here, I'm going to get 0 over 0. So I'm going to take this limit, and I'm just going to put it in here. And I'm going to do the same thing here. I'm going to take this limit and I'm going to put it in there. All right, so I'm going to let h go to 0 just in this. If I sort of highlight this right here, I'm going to let h go to 0. And so I'm going to get f of x. All right, and here, this isn't affected by h at all. So I'm just going to take this limit and write it in there, and take this limit and write it in there. Okay? And so what I end up with is this. And then this is g prime of x. And this is f prime of x. It's the limit definition of the derivative. So we end up with this. Okay? F of x times g prime of x plus g of x times f prime of x. So there's the product rule. There's the proof. Done. It works. Now, you might be wondering what just happened. If that's the case, you don't need to know the proof. But what I'm trying to do with the proof is just show you that these things they come from the limit definition of the derivative. So when we're doing a limit definition of the derivative, and then we say, well, here's all these rules, we're not just pulling them out of thin air. We're just using patterns of the limit definition of the derivative. Okay, so let's just do a few examples to show you how this works. So let's say that's my function, 2x cubed plus 5 times 3x squared minus x. So I just kind of split them and say, there's my first function, there's my second function. Now you have the option of multiplying them out. You could just multiply them, expand the brackets, you know, get 6x to the fifth minus 2x to the fourth plus 15x squared minus 5x, and then take the derivative. And you will get the same answer. But the product rule says, and I'm just going to do it here, I've got it done underneath, but I'm just going to say, first of all, here's 2x cubed plus 5. We're going to multiply it by the derivative of the second function. So I'm going to multiply it by this derivative. So that's going to give me 6x minus 1. And then it's plus the second function, so 3x squared minus x, multiplied by the derivative of this. The derivative of that is 6x squared because of the power rule. Bring the power down, 3 times 2, and then subtract 1 from the power. And the derivative of 5 is 0. So that's my product rule. Okay? Which is what I have there. And then you can simplify that if you want to at that point by expanding the brackets. Okay? But you don't have to, and I'm not going to. So I'm just going to leave it as is. And what I will ask you to do when I'm testing you just on the rules for derivatives, I'm just going to ask you to do this step, this first step. I'm not going to ask you to simplify at all. Because all I'm trying to see is, do you know how to get the derivative? The simplifying is important. You should simplify. But it's more important to me at this point that you understand how to get the derivative. Okay? So here's another example. Same idea, except this one is the square root of x and 2 minus 3x. So we start out by taking the first function, which is root x. We multiply it by the derivative of 2 minus 3x. The derivative of 2 is 0, and the derivative of minus 3 times x is minus 3. Okay, because the derivative of x is 1. If you kind of think about this just by itself, if y is equal to x, then y prime is, that's really x to the 1, so it's 1x to the 0. That's why it's just 1. So the derivative of 3, or minus 3x, is just minus 3 times that. So it's minus 3 times 1, which is minus 3. So that's where I'm getting that from, in case you're not sure, all right? Now, I keep going with my product rule, and my product rule says now take the second function, so 2 minus 3x, and multiply it by the derivative of the square root of x. And that is something that shows up a lot, the square root of x. So I'm just going to go through it over here to show you that root x is really x to the 1/2. So y prime becomes 1/2, bring the power down, and then x to the 1/2 minus 1. Okay, so that's 1/2 of x to the negative 1/2. And what we do typically is get rid of the negative exponent by putting it underneath, and then we get rid of the fractional exponent by writing it as a root again. Okay, so this derivative, the derivative of root x, is 1 over 2 root x. And I'm going to generally skip all these steps. Okay, I'm just going to, this is one, because it pops up often enough, it's better if you just memorize that the square root of x is 1 over 2 root x, because it's going to save you some time. You don't have to. You can always do the power rule, but that's one that's going to pop up fairly regularly. So that's that derivative. And then all we do is just write it out in a little more simplistic form. But we don't have to rationalize denominators or try to put them together or anything like that. For now, I'm not saying you shouldn't. What I'm saying is at this point, I want to test derivative rules. I don't want to test your algebra skills. Okay, maybe I should. Maybe some of you don't have very good ones, but that's what I'm trying to do. So you just have to get to this point or this point, and I'm going to be happy. Okay? So that's the product rule. All right? So let's try this one. It says find the slope of the tangent line to the curve, this, which is a fairly big curve at that point. So what we do is we want to first of all find the derivative. The derivative is going to give us a slope. We're going to go, okay, That's the first function, 3x squared plus 2, multiplied by the derivative. So this is the first function here, multiplied by the derivative of the second. So the second one prime. So we get 6x squared for 2x cubed because the 3 comes down and you subtract 1 from the power, and the derivative of minus 1 is 0. So we get that. Then it's plus the second function. So that's 2x cubed minus 1. And we're going to multiply that by the derivative of the first. So we're going to say the first prime. And so that derivative is 6x, the first one, and the derivative of 2 is 0. So what we want to know is what is the f prime at 1, because that's going to give us the slope when x equals 1. Okay, so we go, that's 3 times 1 squared plus 2 multiplied by 6 times 1 squared plus 2 times 1 cubed minus 1 multiplied by 6 times 1. Okay, so 3 times 1 squared, that's 3, plus 2 is 5. We're going to make this a little simpler, won't do it all at once. That's 6. This is 2 minus 1, so it's 1, and multiplied by 6. So that gives me 36. That's my slope. And then at this point, you have a point, 1, 5, and you have the slope. So you just go y is equal to, I know most of you use y equals mx plus b, so I will show that to you. It's 36 times 1 plus b, so b becomes negative 29. 5 minus 36 is b. I don't think it's negative 29, actually. That's not true. It's negative 31. My bad. So my equation becomes y is equal to 36. Whoa. Computer's going trippy here. 36x minus 31. There we go. So that's the equation of the tangent line. All right. So that's the product rule. And I'm going to leave it there because the time is almost up on the video, the length that I can make. But we'll just practice some more of that in class. But the premise of it is take f d prime plus f prime g.